So here's the Hovercraft. First prototype is complete. Just gonna go through the parts here. It's using quite a bunch of different power sources. This is being the main one. 7.4 volts, 1500 milliamp lithium polymer battery. Very light and powerful for its size. That is controlling my brushless DC motor here, which has 0.5 kilogram of thrust, which lifts the hovercraft up. I plan on using one of these as well for the back, but one of the batteries smoked up, so I was going to use a computer fan just for simulation, but that doesn't have very much thrust, so I took the wings off an old helicopter, and that actually can push the hovercraft. So to power this, it normally just ran off a little 3.7 volt lithium polymer battery, so I just put two AA batteries together to make 3 volts. And to control that fan, I'm actually turning on a transistor here with pulse width modulation. I'm throwing that into saturation, which turns this on. So in order for this fan to work, it's a brushless DC motor. It turns a straight DC wave, this thing does, the speed controller, into a 3-phase configuration in order for it to work. So this here has 3 leads on this side and 3 leads on this side. These 3 going to the 3-phase motor, and one of these is positive, one is negative, and this here is a servo connection, which is basically like which goes to a remote control. I'm using an Arduino here as the remote control. Now I had to use 2 Arduinos because how a remote controller works is it uses pulse width modulation or pulse position modulation, which needs to be updated every 15 milliseconds. So if I had any other code or anything in my program, then that wouldn't work. Even if I used interrupts, it'd be interrupting the system every 15 milliseconds, so it just couldn't get anything else done. I didn't have enough time to figure that out, so I'm using 2 Arduinos. This one here is controlling everything else from, like I said, the transistor, throwing that into saturation. It's controlling the serial monitor, which I'll get to in a minute. That's controlling the servo, and it's controlling, I already mentioned that, sorry. So the way the serial monitor is it's displaying the sensor that is currently being triggered. You can see the sensors here in the front. They are sharp infrared sensors. You have the emitter on one side. It throws out a signal and bounces back off something, and basically gets the reading in centimeters. And there's the other sensor. So if I move this over here, you can see I'm in front of the left sensor. It's your right, but that's the left sensor, and you can see we are getting a reading of 57 centimeters. I can put my hand up closer here. Now it goes down to 6 centimeters. I can turn the hovercraft over here. Now it's getting a reading for the right. As you can see, the servo's moving as its different sensors are being activated. Now I don't have the servo completely centered at default. I have it centered at default, but that's not in the 90-degree position. The reason being is because I want to be able to almost make it completely turn around in one direction. That's so it can turn around better. The hovercraft basically uses 3 maneuvers. Whichever sensor sees something first, the range is 55 centimeters, so whichever one comes to an object within 55 centimeters first, it will turn the servo the corresponding direction and hold it there for a certain amount of time and begin to turn around. So that covers 2 maneuvers. The other one is if both of the sensors detect something. This is for when it kind of gets stuck or is really close to an object. It also throws itself into that furthest servo position so it can turn around with a little bit of an extra delay. And that basically covers different parts as well as how it works. Now I'll show you a demonstration.